Hello everyone and welcome to this SOLIDWORKS 22-minute webinar, 3D for the 2D user. My name is Barb Schmitz and I will be your host. We'd like to jump right in and get started. We have a ton to cover in 22 minutes. So let's get started with our first poll question. And while you guys are answering that, I would like to introduce you to our presenter today. Jeremy Regneris is a Senior Product Introductory Manager. Jeremy has 20 years of industry experience, 17 of which have been using SOLIDWORKS. Jeremy has spent time designing agricultural equipment, automated assembly machinery, to classified vehicles for the defense industry. Jeremy has also worked as an application engineer prior to joining SOLIDWORKS 9 years ago. Since joining SOLIDWORKS, Jeremy has focused on creating rich user content, product demonstrations, and what's new material.
All right, thanks, Barb. We're going to go ahead and get started, and we have a ton of content to cover in the next little bit of time we have, so I'm going to go ahead and dive right in here. So one of the first things I want to do is quickly cover what we're going to be going over. As it relates to the 2D user, we're going to show some of the key differences that a 2D user might face when looking at a 3D design tool like SOLIDWORKS. So we're going to be looking at how to design parts, how to build assemblies, how to analyze those assemblies, and finally how to create drawings with the 3D models you create. When we're finished, we'll have a little bit of Q&A time to ask any questions you come up with along the way. So why don't we go ahead and take a look at designing parts in 3D. This process differs a little bit from how a 2D user would create views and then project that geometry into additional views and then create further section and detail views that might be needed along the way to describe the geometry of how a part would be created. A lot of concepts are similar, but as opposed to creating views, we're going to be creating three-dimensional geometry. So why don't we go ahead and get started by diving right into SOLIDWORKS. One of the first things you'll notice in SOLIDWORKS is we do work with three different types of documents: parts, assemblies, and drawings. And these really differentiate the different types of components you'll be creating. So I'm going to go ahead and start by creating a part. One of the other things that'll jump out right away is SOLIDWORKS works in a concept, because it's in three-dimensional space, we have to choose what we actually want to draw on first. And in this case, I'm going to choose to draw on our top plane. When it comes to creating the actual geometry, you'll find a lot of the same tools you're familiar with inside of your 2D application you're using today. One of the differences, however, is how this geometry reacts. You'll notice that it's very easy for me to move and drag it around. That's because SOLIDWORKS uses the concept of sketch relationships to define how the geometry should act. There, creating an equals relationship, you'll notice that both of these circles always stay the same size. Additionally, creating geometry connecting these two together, you'll notice I can lock in things like it being horizontal and if it's locked to the center of the part. So now you'll notice that as I do this, the geometry starts to gain a bit of intelligence. Like snaps in your 2D design tool, you'll notice that SOLIDWORKS intelligently snaps to the geometry. Here, as I move this line across this arc, it automatically snaps to the tangency. So I don't have to spend time creating all those relationships. A lot of them are created automatically. Additionally, things like patterns and mirroring geometry that you're used to in a 2D design tool, those are available in here as well. Likewise, trimming is a common thing that you might have to do in a 2D design tool. Once you have the shape, though, you'll notice we've done nothing to really specify the size of this. We've just haphazardly drawn this geometry. This is where the last type of relationship, and probably the most important, comes in, and that's a dimension. You'll notice we use one dimension tool inside of SOLIDWORKS, and by adding these dimensions to the geometry, we're able to adjust how the geometry looks and shapes. You'll notice that some of the geometry is turning black, and that's telling us that it's been defined. Here I can quickly see what geometry hasn't been defined. Let's add one last relationship here, and in this case we'll just throw a radius on there. So once we've defined this, we do need to turn it into a 3D object now, and I'm going to rotate around using my middle mouse button. Now here's where things really differ from creating stuff in 2D. Instead of projecting the geometry onto a different view, I'm going to go ahead and I'm going to choose to extrude this. So it's kind of like doing the projection, but instead what I'm doing is I'm just dragging and defining a size on screen. And you'll notice here that I choose 7 millimeters and I get the 3D geometry. Now continuing on, instead of just drawing everything on the front view, you can actually draw on the faces where the actual features will reside. So in this case, Let's go ahead and look straight at it. I'm going to create a rectangle. And I'm going to enter some dimensional values here. So we'll put the width in, but you'll notice I'll leave the vertical dimension off because I actually want to capture this with another one of those intelligent relationships. As that's created, like before, I want to project this. Just grabbing on the geometry and dragging it allows me to either create geometry or remove geometry. SOLIDWORKS tries to understand what you're trying to do, and it makes an assumption. Sometimes that assumption isn't always what you're looking for, as is the case when I create this circle here. I'm going to go ahead and throw a dimension on there really quick, and that's going to be 21. So when I go ahead and I go to perform that same procedure again, when I drag it through the part in this case, you'll notice that it cuts the material. Well, I wanted to add material in this case. Well, when I release my cursor, SOLIDWORKS does always give you the opportunity to make a change as needed. Let's do one more feature here to show one more way you can do this type of thing inside of SOLIDWORKS. We'll just specify our diameter. I've been clicking on it and dragging it. You can also choose from a variety of features, and when doing so, you get many more options over here on the left-hand side. So you really have full control over how that geometry is created. But drawing and choosing a feature isn't the only way. A lot of things can be done by simply selecting the geometry, things like chamfers and fillets. Here you can see I can quickly and easily apply in a chamfer, select a distance, select another edge, and press OK, and they're added quite quickly. We'll do the same thing with a fillet here. If I grab this edge and choose fillet, specify a radius, and I'll go to select a few more edges, and SOLIDWORKS even understands that there's other edges around that are similar to the one you just selected on. Notice by selecting that option, it automatically grabbed all 6 of those. Some features are more than just geometry though, and we want to add a little bit more intelligence. In this case, what I'm going to go ahead and do is I'm going to create an intelligent feature called a hole wizard hole. Now a hole wizard hole is a little bit different. I'm going to go ahead and I'm going to place where I want the centers of my holes to be. And you'll notice I grab the edge and it automatically snaps here to the middle. When I go to define the actual hole itself, you'll notice we have a wide variety of hole types we can create, from counterbore holes, we can create countersunk slots, a variety of different types of holes. But in this case, what I want to do is I want to create a countersunk hole, and instead of typing in the dimensions for the size of the hole, we define it based on the information you would typically find in, say, the machinist handbook. I choose my standard I want to work with, the type of fastener, and the size of the fastener, and when I press OK, SOLIDWORKS just creates the correct geometry. I don't have to focus on what those dimensions are. One last thing about defining parts. It's also more than just creating 3D geometry. You'll notice here on the left we have something called material. We can apply actual materials to our parts, and these will impact it in several different ways. Now these are my favorites. I'm going to go into an extensive library that SOLIDWORKS provides, and I'm going to go ahead and choose a custom material, in this case aluminum bronze. Now you'll notice it does define things that will be used in drawings, such as a crosshatch. These are common features found in 2D design tools. But it also applies in appearance. Notice when I click apply, it takes on the appearance of a polished bronze. But most importantly, it applies things such as physical properties, which can be used to calculate the weight, but also later on in designs, understand the physical strengths of the materials. So take a look that now that we've defined a material, we can go to mass properties and get the actual weight of our part right here. But again, you can take it a lot further than that. So let's go ahead. So we looked at designing parts in 3D, but we need to put those together. And that's really where building assemblies comes in. Doing this in 2D is very similar to creating parts. You insert X references or blocks and explode them, and then move that geometry around and position them correctly. And in a single view, this works out just great. It's fairly simple to do, but what happens when you need other views to describe this? You end up creating a lot of geometry throughout the design process. And then furthermore, you get into complex scenarios such as section views and detail views, and finally things like bills of materials, which we'll take a look at when we look at drawings in a little bit. So let's take a look at how this process works inside of SOLIDWORKS. I'm going to go ahead and close this. I'm going to open up an assembly that's already been started to show some key concepts. Building assemblies in SOLIDWORKS is fairly straightforward. You simply select geometry you want to assemble to one another, and holding down the control key, and SOLIDWORKS gives you some quick choices here based on your selection. Notice because I selected 2 cylindrical objects, I get a limited selection. When I choose concentric, those parts go together. When I click 2 flat and circular faces, I have more choices. I can make them touch one another, or I can take it a step further and not only make them coincident with one another, but also aligned to one another. So here I'll go ahead and press OK. There's also some faster ways of doing this. By holding down my Alt key while dragging the cursor, you'll notice that geometry is intelligent. It understands that it's a cylindrical face. It may want to attach itself to an additional cylindrical face. But you're always given the option to make any changes from the defaults that SOLIDWORKS suggests. Now you'll notice that when we put the geometry together, we're not just placing it. It also contains movement inside. And in this case, this part's free to move up and down. This is a great place where a section view could really come in handy. Now I'm not talking about section views as they relate to a drawing or documentation. We use section views in 3D to get a better understanding of how our components look and the ability to see inside of them. And in this case, I'm going to choose the option to only section the components that I select. So when I do this, you'll notice that I've sectioned the 2 housings, but I'm still able to move and interact with all the other components. Now I can see what I want to do. I want to attach this edge to this face right here, and when I select those 2 components are now locked together. Likewise, this handle is still very free to move. We've shown very quick and easy to create mates, but SOLIDWORKS has a full depth of tools to achieve these within what's called the Mate tool. Here you can see the simple options we've chosen before, but we can go into advanced options and create things such as a limit. In this case, we're going to define a limit of a maximum of 90 degrees and a minimum of 0 degrees. When we apply that, you can now see that the motion is limited based on that. So we can really control how our parts work together. Let's dig a little bit deeper here. The next thing we want to do is we want to add some additional components, and I want to get things out of my way. Instead of turning layers on and off, I can very easily come in here and just isolate components to view just what I want to look at. We're going to go ahead and insert some other components that we've created already. I'm going to go into my Open dialog box, choose those, and press Open. Now you'll notice that when I bring this part in, it actually already understands how it's supposed to be located in place. This is due to the nature of how we created the file. Once I find the appropriate spot, I simply click, and this file is actually a family of parts. I can choose between a 5-seal version, a 4-seal version, and a 3. When I choose 4, you'll notice the geometry changes. It then brings up the next part that I wanted to insert, and we'll locate that again. A quick moment about this part that we changed before. You'll notice that at any time you can go in here and you can actually change this to another version of that. That's great for looking at different design iterations where you want to potentially change which version of the part you're using. So that's inserting existing components, but let's take a look at a part that we might be designing already. In this case, we want to insert this component in here, and I've just simply tiled my windows. You'll notice it's actually quite easy to drag and drop the geometry, and by choosing an edge, SOLIDWORKS, it's kind of like when I held that Alt key a minute ago and I dragged it, it understands that it wants to attach to another edge within the file. So I'm going to go ahead and exit my section view here. You'll notice that this part is still free to move. Here's where I'm going to use that Alt drag to, again, just quickly assemble those components. Now, hardware needs to go into our designs, and SOLIDWORKS actually provides a vast library of standard hardware based on industry and international standards. In this case, I'm looking for an ANSI metric bolt. It's going to be a hex head, and I want a cast screw. Assembling components like these are even easier. You'll notice that as I drag it across holes, the geometry automatically starts resizing itself to the hole that I've dragged it on. You'll notice when I let go, it's already chosen an M8 fastener for me in this case, though I can change it if I want. Likewise, you can adjust the length of the fastener by just simply clicking on the arrow provided and dragging it down. Once you have exactly what you want, simply press the OK button, and SOLIDWORKS will ask you if you want to add any more of these. And in this case, I'll just select the other hole on here and press Finish. So we've added our fasteners that way. There is one last final way. What if you want to create those holes and the fasteners all at once? SOLIDWORKS provides a very powerful tool for this inside of assemblies called a hole series. Now a hole series starts by allowing you to select where the centers of the holes are going to be. And like we did in the part, I'm simply going to hover over these circular edges and SOLIDWORKS will highlight the center for me, making it really easy for me to snap to that center point. And when I look at the preview, you can see SOLIDWORKS is going to create a series of holes here. Now we can go through and further define these. So for example, I have a screw clearance hole here. Well, what if instead I wanted to put a countersunk hole? Like we did before, we choose the standard, we choose the type of fastener we want to apply. Again, we don't have to worry about the dimensions in this case. We specify any middle components, and finally our end termination component. Now in this case, it's creating a screw clearance hole. We can change that to a slot if we want to in this case. Additionally, we can change how it terminates. Now I don't want it to go through the entire part. I want it to stop at this face. And then lastly, we can also automatically include the fasteners. SOLIDWORKS gives us a quick preview of what we'll be creating, and we can add additional fasteners from the pull-down menus on the left. For example, we may want to put a flat washer on here and a jam nut. Now notice that as we do this, the fastener's length automatically updates to make sure that it accommodates the proper thread engagement for those fasteners. So it's pretty quick and easy to quickly put that geometry in place. So we've looked at how to build parts, how to build assemblies. Before we look at analyzing assemblies, why don't we take a look at our next poll question, Barb?
Sounds great. Thank you. So our next poll question is, what are your challenges when using your 2D design tools?
Great, thanks, Barb. So one of the top items there was finding interferences and collisions and excessive time spent during the design process. These both really appeal to one of the next topics we're going to be looking at, and that's analyzing our assemblies in 3D. So we've shown how to create geometry. Let's talk a little bit about the value and what we gain out of it. Finding problems in our designs is really important, and this is really what 3D allows us to really find and get to the root of. One of the first things that engineers often run across is parts just lining up properly, and hole alignment is a great tool for this. When I choose hole alignment, it quickly shows me any holes that are misaligned on my design, and I can easily zoom to those specific areas. I can even go deep into this and get a better understanding, and in this case I can see it's a 0.5 millimeter off. In fact, both of those holes are. So why don't we go ahead and use those same tools we saw before to quickly narrow down where this problem is coming from. So I'm going to create a section view and isolate those components. Measurement's a great way to quickly find these problems, and if I look at these two holes, I can see that they're 38 millimeters apart, and if I look at the two holes below, I can see that they're 39 millimeters apart. That's because in SOLIDWORKS you can create geometry by just typing in numbers. But why don't we go ahead and fix this problem and take a look at another way. So I'm going to edit the feature that I had created, and here you can see the 39 millimeter dimension. Now of course I can change that to 38, and there I actually typed it wrong. But a smarter way to do this is to use some of those relationships we talked about earlier. In an assembly, I can create a relationship from one component to another, and in this case, make sure that the centers of these holes will always be concentric with these. These will eliminate errors like that from even happening in the future. So let's go ahead and go back to where we started from. So let's see if there's any more hole misalignments. Choosing Calculate says there's none. So we fix that problem. Another thing users often run into are interferences between their components. Finding these in a 2D design can often be challenging, as you kind of have to dig around and look for overlapping lines and things like that. In SOLIDWORKS, it's a button click to do interference detection, and we can quickly choose Calculate. Now you can see there's a whole host of interferences in these designs, but it looks like most of them are actually the thread engagements for how I've created my fasteners. SOLIDWORKS accommodates this by creating a matching cosmetic threads folder, allowing me to focus on the actual interferences in my design. And like before, we can right-click, zoom to selection, and quickly find out where that problem is being caused. In this case, we can see that our handle is interfering with the head of our bolt. So how do we fix that? Well, like before, we saw that we can change dimensions on the fly. In this case, I'm going to just double-click on this part, and I'm going to find the dimension that's defining the hole spacing. It's the same 38 millimeters we were looking at before. Now when I change that to 41 and I choose to update, you'll notice that the geometry updates, but actually more importantly, that hole that we created before updated as well. So there's no changes to worry about on that part. Now when I go in and I perform an interference detection again, we can see that we have none. Now interference detection is great for static components, but I've shown you already that these components actually move through a range of motion. Using the actual move command, we can go a step further and we can do something called collision detection. As I grab the handle, you'll notice that as it gets near the head of that bolt, it actually stops and highlights two faces that are colliding with one another. As we did before, we can remedy this problem by changing a dimension. I'm going to choose 7 millimeters and choose to update it. And you can see that the geometry updates accordingly. Let's go ahead and click Move again. And this time we're going to enable something called dynamic clearance, where we're going to check the distance between these components. And let's go ahead here. Now you can see what's happening. We're getting a dimension that's appearing, showing us the minimum distance between these components. And you can see that appear down here. This is important for things that might change due to mechanical conditions, and you always want to maintain a certain level of clearance between those components. So that's an example of just a few of the things that you can find inside of SOLIDWORKS. Let's go ahead and I'm going to quick jump over that. And we're going to look at one of the last things that users always want to know is, I've created the 3D models, how do I go about creating drawings inside of SOLIDWORKS? Well, we kind of understand how we do that in 2D today. What I want to do is I want to look at how do we do that with SOLIDWORKS. And let's start with the basics. Let's start with a part design. Because we've added so much intelligence to the part, creating drawings almost comes, you could say, for free. What we do is we start a drawing and choose the size that we want to create. So it's a little bit different. Instead of starting with, say, paper space and adding that on, we're creating a drawing document instead. And then we're given a list of standard views that are created from our model. Here we have options to import those dimensions that we use to create the models. And as we drag and drop these views out onto the drawing, you'll see that SOLIDWORKS automatically places any appropriate dimensions in those views. And by simply dragging and dropping, we can add as many views as we want. These are projecting off from this top view, but notice I can select any view and choose to create additional projected views off from them. Likewise, you can always go back to the view palette and add any additional views. In this case, maybe an isometric view would look nice. And if we have a 3D, or if we have a color printer, we can actually change the color of this as well. This would really make it stand out and easy to understand what it is. Now these are very simple views, but why don't we take a look at something a little more important, a section view. Section views are actually really easy to create in SOLIDWORKS. You'll notice by hitting the Tab key on my keyboard, I can change between where I want the section to be, and it snaps to geometry. Once I click, SOLIDWORKS gives me the option to create any jogs that I might want, which I don't in this case, and we simply place the view. We can also change things like emphasizing the outline, slicing only or showing only the section surfaces themselves. And as these dimensions are placed, you have full control over what you want to see. For example, I might not need to see those dimensions, so I can turn them off. We can clean up the views quite easily. So for example, if I want to change where this label is going to go, you'll notice that everything kind of snaps into place to keep everything nice and aligned as well. If you want to put something on another view, it's as simple as a drag and drop, and you can go add that to a different view. Now, there's a few other cleanup things you might want to do. For example, we might want to change this and add a note to it. By selecting it, we can very quickly add things on the fly. For example, typical in this case. What about dimensions that aren't included in the design? Well, you can add any number of dimensions that you'd like to as well. In this case, we want the overall height. So we'll go ahead and place that, but you'll notice we can also quickly access things and call this out as a reference dimension. Let's add one more dimension here, and we'll place this one, and we'll do the same thing. We'll make that a reference dimension as well. So we've added all these dimensions, but as I mentioned, the dimensions in the drawing are actually those we use to create the file. Creating change is really important, and creating changes in SOLIDWORKS is quite unique. Because this 12 millimeter dimension was actually used to define the height in the part file, I can actually double-click on it here, and I can actually make changes to it as needed. Notice when I click Update, it actually updates everywhere on the drawing. I don't have to go back and change each one of these views to reflect that really simple change. It's all done with a simple double-click and changing the dimension. But what about assemblies? They're a little bit different, and they have some more use cases to them. We're almost done here. Let me get this quick opened up. We're running just a little bit over, but we'll be done in just a moment. So one of the last things we want to look at is how can we leverage drawings with our assemblies? Well, like before, we can create complex views like a section view. Now, in this case, I actually want to create a half section. A half section is a great way to see both the internal and external components in an assembly. I can also place this view wherever I want or snap it to always stay in line. I'm going to move it off to the side a little bit. Because SOLIDWORKS leverages a 3D model in the background, we can actually customize these views in any way we want. For example, rotating it around or even setting it to a standard view. When I press OK, SOLIDWORKS will update that view. We can also customize our section views to section just the items we want. So for example, if we don't want to section this handle, this shaft, or this ball, it's really easy for me to exclude those from the section itself. This is a really great way to get a clear understanding of this file. Another thing we can do that's unique to assemblies inside of SOLIDWORKS is creating a type of view called an alternate position view. Alternate position views leverage different configurations that we may have modeled our designs in. In this case, I am showing open, and I also want to show closed at the same time. This is really great for things like dimensioning between the minimum and maximum constraints of a design. Here, I'm going to go ahead and just quickly add a dimension to that. Likewise, in an assembly, we may want to show a nice exploded view. Now, I've already generated the explode steps in the assembly, but I want to show how easy it is to enable that here in a drawing. Now, assembly documentation wouldn't be complete without a bill of materials. And SOLIDWORKS handles this by looking at the individual files and reading the properties of those files. And this captures things like, in our case, the number or the description. Now, you can customize this to include any values that you want. But now that we've got a bill of materials, we also need to balloon our design. Let's get this out of the way a little bit. SOLIDWORKS can handle this by using auto balloon capabilities inside of SOLIDWORKS. I'll do this and I'll quickly choose to auto balloon it. SOLIDWORKS will put a balloon on every single component, and in this case it neatly placed them around our design. Now you'll see here that the balloon numbers match the bill of materials. But what if I wanted these balloons to be in a different order? Well, SOLIDWORKS allows you to order them sequentially, and you'll notice that when I did that, SOLIDWORKS automatically reordered our bill of materials for us. This ensures that everything is always in sync, no matter what I do. So I'm going to go ahead and quickly clean this up because maybe I want to position these a little bit differently. You'll notice that SOLIDWORKS does a good job of keeping everything snapped together as well. So we've taken a look at how we design parts in 3D, how we put those assemblies together, how to find problems inside of our designs because of the power of 3D, and finally how to create rich drawing documentation of our 3D models. Now we're going to go ahead and we're going to move on to a Q&A section.